Assalamu alaikum. Hello everyone. I hope you are fine and well. Today we have to talk to knowledge to repair TV panel. Okay, there is many problem in a panel TV. We have to talk with the type of LCD, LED TV screen problem. Okay, there is many problem like first, no display. No display have many problem. Okay, 2, display upside down and painting display problem. Number 3, white display. Okay, number 4, display with slow motion. Number 5, display double image or jumping image. Number 6, wall screen of vertical color lines, static or dynamic. Number 7, screen display divided to several sections or displaying content opposite. Number 8, one of several horizontal vertical bar or lines on screen. Number 5, abnormal display, not mention the above. Okay, we have to talk to TCON. TCON have many duty to do, like signals and voltages. Okay, the principal voltages of VCC are 12 volt. Everyone know this. Okay, 12 volt, they have many power sequence in TCON, like TCON of LG or a TCON or other brands. Okay, let's take an example first. I have mentioned every abnormal screen. It's not the problem from screen. Okay, let's talk for example for principal VCC V in. Okay, V in, it's 12 volt are coming from motherboard. The 12 volt are projected from PSU to motherboard to TCON, from a MOSFET go directly to panel. Okay, 12 volt is not, there is 12 volt, there is no screen, there is a black screen. Okay, if there is no 3.3, there is no screen. If there is no 17 volt, there is no screen. There is essential voltages from the layers screen or display screen. Okay, if there is example for VGH or VON or VG on and VGL of or VG VON or VOF or VGL, if this 2 voltages is missing or abnormal, the screen will become slow motion or abnormal display. Okay, let's talk to of VCOM or common voltage. Okay, let's explain. For example, I say VGH and VGA. There is the voltages for a gate high for VGH and VGL for voltage for gate low. Okay, V in, there is principal voltages for VCC TCON. Okay, VDD, there is a voltage for digital, okay, and VAA or VDA, there is voltage for there is analog voltage, okay. This is essential voltage for screen. The terminology of TCON board or a panel PCB LCD LED, like a marketing code on TCON, V-on or VGH or VG-on or VDDG. This gate on supply VON is a positive supply, okay. There are about 20 volt to 35 volt, okay. CKV, CKVB and STVP, it's a high voltage driver output, okay. It's a high voltage driver output. The supply, the positive supply for a CKV and the CKVB and STVP, high voltage driver output, bypass to GND with minimum 1 microfarad ceramic capacitor, okay. This VGH or gate high voltage was generated by the DC to DC circuit, okay, and their voltage about, I say, 20 to 35, will depend to TCON board design, okay. VGH voltage is supply gate driver board and switch on it can switch the TFT cells, okay. It's driver cells. This VGH are driving cells of LCD panel, okay. Cells like every pixel have a 3 cell, okay. VGH drive every cell, every 3 cell is a pixel, it's okay. Let's talk for VGH, VGL or VOF or VG-OFF or market to VEEG, okay. This gate are off supply, off low supply. This gate is low supply or off supply, okay. It's a negative supply, it's a negative supply voltages of for what? For the same signal of CKV and CKVB and STVP for a height driver output, okay, are bypassed to GND with a minimum 1 microfarad ceramic capacitor, okay. This gate low was generated too from DC to DC, okay. Some TCON will use high voltages as 15 volt or a lower voltage as -1, okay, will depend with the TCON design. Typically voltage for VGH or VGL or VG-OFF or VEEG are -5 to -8, commonly are -5 to -8. Okay, this negative voltage is supply gate driver board VGL voltage, switch off when VGL negative voltage is supplied. The VGH voltage on TFT cells will clear by VGH voltage, okay, and the next data can show the TFT cells, Let's talk for digital voltage or VDD or V-logic, marketing code V-logic or VDDD or DVDD. This VDD voltage supply input is the logic supply input for the scan driver. Okay, for the scan driver it's bypassed to GND through the minimum 0.1 microfarad capacitor. Okay, this V-logic or VDD voltage is output from DC to DC2 or using an external voltage like regulator IC to generate it to IC to generate, okay, from external regulator IC. Voltage of VDD and V-logic and VDDD or DVDD is 3.3. okay, other voltage with other brands like VDD 2.5 and 1.8 was using the VDD 3.3 to convert after VDD voltage generated. Okay, timing controller section, source driver and gate driver board. This 3.3 its voltage for a digital are generated from DC to DC. Okay, let's talk about AVDD or VDA or VDDA or V-source. This voltage are about 14 to 20 volt and will depend or other design for TCON board. Okay, this VDA voltage is generated by DC to DC. Okay, this voltage is used to supply a gamma circuit. Okay, it's used to supply a gamma circuit to source driver volt. It's between 13 to 25 volt. This voltage for AVDD or VDA or VDDA or V-source. Let's talk about a VCOM, okay, or a common voltage. Common voltage, it's nearly a half of AVDD voltage. Okay, AVDD voltage, if there is 17 or 16, VCOM are about half of this voltage, nearly half. Okay, are 7 volt, maybe sometimes 6 volt, maybe sometimes 8 volt. This is about the designer. Okay, let's talk with EGND. It's a ground. Okay, BGND are a non-amplifier ground. Okay, and GND are a logic ground. PGND, it's motioned like this for PCB design. Okay, marketing code. PGND, it's a power ground. For power ground, let's take an example. There is a source of connection for internal, for example, step up regulator power switch. There is a PGND. To know this PGND are with PVCC, for example, number I don't know. Okay, this is an example. PGND are for power ground. STV, that's mean a vertical sink. vertical synchronization. Okay, there is a rising edge of STV when begin a frame of data. Okay, at the beginning of frame of data, this rising edge of STV begin. Okay, and STV input is used to generate a high voltage for STVP output. Okay, I have to talk with STV. Now we talk with STVP. There is a high voltage scan driver output. Okay, is connected to V off when STV is low. When STV is low, STVP is connected to VOF and connected to VON when STVP is high. Okay, when STVP is high, VON connected to VON when STV is high and CPV1 is low. Okay, when both STV and CPV are high, STVP is high impedance. CPV, its abbreviation, CPV1 it's an abbreviation for clock pulse vertical. Okay, a vertical clock pulse input CPV1 control the timing for CKV1 and CKV-B1 output, which change by state by first sharing charge. CPV2 clock pulse vertical input. Okay, CPV2 control timing of CKV2 and CKV-B2. Clock pulse 3 or CPV3 control timing between CKV3 and CKV-B3. Okay, it's control CPV1 control CKV1 and CKV-B1, CPV2 control CKV-B2 and CKV-B2, like this. Okay, let's talk about CKV1. CKV1 or clock signal, high voltages scan drive output. Okay, when enabled, CKV1 it's been between its high state connected to VON. Okay, and it's low when it's connected to VOF or VGL. Falling edge of the CPV1 input, CKV1 is high impedance whenever CPV1 and STV are both low. Okay, CKV2 high voltage scan driver. Okay, output when is enabled, CKV2 toggle between a high state connected to VON and low state connected to VGL. Okay, they each falling edge of CPV2 because CPV2 control CKV2 and CKV-B2. Okay, CKV2 is high impedance whenever CPV2 and STV are both low. Okay, and the same for high scan driver for CKV3 when is enabled, to high state it's connected to VGH and low state connected to VGL, which edge falling edge of CPV3 it's further to CKV3. It's high impedance whenever CPV3 and STV are both low. Okay, let's talk about inverted clock signal like CKV-B1. CKV-B1 it's a high voltage TCON drive output. Okay, CKV1, it's an inverse of CKV1. CKVB1, it's the inverse of CKV1 during an active state and high impedance whenever CKV is a high impedance. CKVB2, high voltage TCON drive output. CKVB2 is an inverse of CKV2 during active state and high impedance whenever CKV2 is high impedance. CKVB3, it's high TCON driver output. Okay, CKVB3, it's the inverse of CKV3, like CKVB2 P2 and CKVB1. Let's talk for a CKV CS1. CKV CS1, there is a clock signal of clock charge sharing connection. CS for charge sharing connection. Okay, it's connected to CKVBS1 whenever CPV and STV are both low to make CKV1 and CKVB1 a high impedance, to allow CKVB1 to connected, I suppose, to CKV1 sharing charge between the capacitive load. Okay, and CKV CS2, CKV2 charge sharing connection. CKV CS2, it's a clock charge sharing connection. Okay, connected to CKV BCS2 whenever CPV2 and STV are both low to make CKV2 and CKVB2 high impedance, to allow CKVB2 to connect to CKV2 sharing charge between the capacitive load of two outputs. Okay, the same example for CKV CS3, there is a charge sharing connection. CKV CS3 connect to CKV BCS3 whenever CPV3 and STV are both low to make a CKV3 and maybe CKVB3 are high impedance. Okay, to allow CKVB3 to connect to CKV3 to sharing charge between the capacitive load. Okay, there is, I suppose, let's talk the same signal for inverse signal of CKVVS and CKVBCS. Okay, this is charge sharing connection. Connect to CKVCS1 whenever CPV and STV are both low to make CKV1 and CKVB1 high impedance, to allow CKV1 to connect to CKVB1 sharing charge between the capacitive are low. And the same example for CKVBC2 and CKVBCS3. Okay, let's talk about a boost. Boost, it's operation amplifier, supply input connect to V main. Okay, and comp, we have to talk to boost. It's operation amplifier, supply input connected to V main and bypass to BGND with 1 microfarad or greater. Okay, let's talk about comp or compensation. COMP. compensation input for error amplifier. Okay, connected a series RC from comp to analog GND to AGND, typically value for 120 180 kilo ohm and 470 picofarad. Okay, let's talk with the Wolf discharge or DISH. Wolf discharge connection is pulling a dash below ground to activate an internal connection between Wolf and GND. Rapidly discharged, the VOF supply typically discharge capacitively is capacitively connected to VDD. Okay, so that when VDD falls, VOF discharge. Okay, let's talk for abbreviation DLY. There is startup delay setting. Connect a capacitor to adjust the delay of delay of time. Let's talk with the EN. This is abbreviation for enabler. To enable the scan IC drive, enable a high to start up the scan IC after the delay time. Okay, which is set by capacitor and delay. And FB for the feedback. A feedback is input reference voltage is 1.2 nominal connected to external resistance to external resistor divider. Okay, midpoint here and minimize trace area. Set V out according to 1.2 under 1 plus R1 divides R2. This is a rule for voltage divider. Okay, let's talk about the G off or gate off supply. Gate off supply, it's a negative supply for a voltage for CKV and CKVB and the STVP. A high voltage driver output, I say it's bypassed to AGND with minimum 1 microfarad ceramic capacitor. Okay, G on, it's a gate on supply. It's a positive supply for CKV and CKVP and STVP. Okay, with the high voltage driver bypass to analog GND or IGND with the minimum 1 microfarad ceramic capacitor. EN or step in regulator supply input are bypassed to AGND with AGND with 1 microfarad or greater ceramic capacitor. Okay, let's talk about LX or switching node. Connect to inductor, coach diode here with minimized trace area for lowest EME. NEG, it's operation amplifier inverting input. Okay, OA or OE, it's active high gate. It's active high gate pulse output enabler. Okay, it's abbreviation of output enabler, OE. Okay, for this is output enabler for CKV and CKVB. Leave the floating charge sharing state on the rising edge of OE. OECON or OECON, it's active low output. There's the inverse of OE. Okay, it's active low output enabler timing input. Okay, OECON is driven by a filtered version of OE input signal. Okay, when we remain long unit for the resistance to charge a capacitor up, OE-CON threshold. The OE signal masked until OE goes low, okay, and the capacitor is discharged below to threshold through the resistor. And the abbreviation of out is adjustable sync current output. Out connect to the resistive voltage divider of op-amps or operation amplifier input between a boost and GND, okay, to determine the VCOM output voltages, okay. E out lower the divider voltages by a programmable amount. POS, it's operational amplifier, not inverting output, maybe not inverting input, okay. SET, SET, it's a full scale sync current adjustment input connector resistor. Abbreviation are AirSet, okay, from SET to GND. To set the full scale adjustable sync current are VBoost device, VBoost device between bracket 20 multiplier AirSet, okay. This is a rule for this, and equal for the current through AirSet. VCOM, its operation amplifier output. VL 3.3 on chip regulator output. The regulator power internal analog circuit by step up regulator op-amp and VCOM caliber, okay. External load to 10 milliampere can be powered by bypass VL to GND with 0.22 microfarad or greater ceramic capacitor. WPN is active low write protect input, okay. Write protect input, this WPN is low when I2C or I2C command are ignored and the VCOM caliber setting cannot modify it. WPN, it's write protected input. WPP is write protected output, okay. This WPP, it's inverse of WPN. XAO, it's in order to resolve problem for image retention effect for a TFT LCD. The technique of XAO function, power off control, is mostly used to present. At present, XAO function mean the XAO to set low level when the display is turned off, okay. His function is turn off. His function, it's set low level when the display is turning off, okay. And GSC, this is a gate shift clock. 2 clock signal for GSC or gate driver IC occur for horizontal synchronous interval, okay. And GSC pulse is generated for the clock signal. The gate driver IC or start pulse has occurred when the set operate the gate. GOE, gate operation enabler, is timing control for supplying gate operation enable, okay. GLE, it's a signal for a gate driver reset circuitry playing. Okay, GSP, it's a gate start pulse. Okay, and POL, POL, it's for polarity reverse. SSC, it's a source sampling clock. SOE, it's a source output enable. Okay, and SSP, it's a source start pulse. This is all voltages essential for a panel and signals, and every signal and his duty to work, and every voltage and his work. Okay, at the next video I will talk for a lever shifter and IC gamma. Okay, it's essential, this two IC, it's very essential for a TCON board. Okay, see you soon at the next video. Okay, bye.